Hello students. We will continue with Chapter 2. We have switched over from measures of centrality to measures of variability. So as the PowerPoint says, it refers to how spread out the data is from the average. So the variability, or how spread out, the dispersion of the data away from the mean. So there's a few different measures of variance or variability that we will cover. The first one, the most basic one, is the range. It is simply the highest value minus the lowest value, or in Excel we can find the range by looking at the max and the min. So max minus min will give us the range. The variance uses this symbol here, sigma squared. The variance is a squared value, is the average squared deviation away from the mean. The standard deviation looks at that value, is simply the square root of the variance. So when we are calculating the variance or the standard deviation, we first have to find the variance when we are doing the calculations on paper. And the standard deviation is one of the best measures of dispersion for the data. This measure is something that we will talk about in later chapters 6, 7, and 8 as well. So we're going to look at a few examples in this PowerPoint, and then a couple examples from the course package on page 30. But first of all, we have these two data sets, set A and set B, with 4 values in set A and 7 values in set B. So let's go back into Excel, and here's our data set. These are the 4 values. The first thing we need to do in order to calculate variance and thus the standard deviation is to calculate the average. So equals average, highlight those 4 values using Excel. If you're not using Excel, it's just 6 plus 3 plus 5 plus 2 divided by 4. We're going to get an average value of 4, making sure that it is more than one decimal place. So the first thing we're going to do is, in this column, is x, the x value minus the average. So 6 minus 4, let me just put this on here, 6 minus 4 equals 2. 3 minus 4 is negative 1. 5 minus 4 is 1, and then 2 minus 4 is negative 2. And then this last column, x minus the average, and let's do like that. So we are basically squaring the value we found, the answer we found in that second column. So 2 squared is 4, negative 1 squared is 1, and then 4 again. We want to add up these values. So 4 plus 1 plus 1 plus 4, should see that is a value of 10. And the variance is going to be 10 divided by 4. 4 because there's 4 pieces of data. There's 4 x's. So the variance here in this case is 2.5. The standard deviation, remember, is the square root of the variance. So the standard deviation is going to be, in Excel, we can find that by going SQRT into that variance number, and we calculate the standard deviation. Standard deviation is 1.58. Now that value by itself doesn't tell us how spread out the values are in that data set. We would need to compare the variance or the standard deviation to similar numbers from a different data set. So let's work with set B to calculate the variance. So once again, the first thing we need to do is find the average of the 7 values in our data set. So 5 plus 8 plus 7 plus 4 plus 3 plus 6 plus 9 divided by 7 will give us an average value of 6. And let's calculate, There we go. There's our average of 6, and we have 7 pieces of data. So I'm just going to put this up here. N equals 7. I should have put this up here as well. N equals 4. So we have 2 columns that we need. X minus the average in that first column, and then X minus the X minus average value squared. So 5 minus 6, negative 1, 2, 1, 2, negative 2, negative 3, 0, and positive 3. And in that second column, or that third column, we square those values. And so those are the square values, and then we add these values up, and we get a total of 28. So the variance equals 28 divided by 7, because there's 7 pieces of data in our data set. That gives us a variance of 4. The square root of 4 would be 2. So when you're doing this work, you can also use these functions, VARP, and this is something that is in one of the lab exercises. We can use Excel to help us find the answer. So VARP bracket, highlight all the X's, and we get a value of 4. We can do the same thing with this function, STDEVP bracket, highlight all the data, and we get a standard deviation of 2. So when you're doing some of these practice questions, do it on paper, and then plug those numbers into Excel and use those 2 functions to help you find the answer. So those are the functions that I used. And this is the one I use for the standard deviation. Of course, you have to, within those brackets, you have to highlight all the values, all the X's. So let's look at, on page 30, just for a couple more examples, we have 2 pieces of data. Let's bring this over here for a second. Sorry, there it was. There's data set 1 and data set 2. These are the numbers we worked on when we calculated the mean and the median and the mode back in measures of centrality. So now we're going to use the same data sets to calculate the variance and the standard deviation. So here's the data sets I have over on the side. Now, for simplicity, I find it easier to work these numbers in columns. So I'm just going to correctly enter these numbers, down the side, 3, 4, 4, 8, 10, 11, 15, 17. Because I'm a guy that needs balance in my life, I need to make sure all those numbers are the same size. So there is data set 1. So once again, the first step we need to do is calculate the average. The average is equal to 9, and we saw that earlier when we were working on the mean and median. The average is 9. The first column we need, I'm just going to go over here and steal the headings, is the first one is X minus the average. So this is going to be negative 6. 4 minus the average, 8 minus the average, 2, 15 minus 9, 17 minus 9. Those numbers all have to be the same size for this to work out, or for me to keep balance in my life. Okay, and then that third column is squaring that number. So negative 6 squared, 36, 5. There. So we have squared that middle column. The following step is to add up that last column, and we get a value of 192. And then we know that the variance is going to be basically 192 divided by 8. Why 8? Because we have, I should have that up there, n equals 8. We have 8 pieces of data in our data set. All those pieces of data, there is the count, which equals 8. So the variance, 192 divided by 8, is 24. And once we have the variance, we can easily calculate the standard deviation, which is the square root of 24, 4.89. Now, once again, to highlight this, you can use Excel. You can enter those values into Excel and have Excel calculate the variance. But you will need to do this on paper, so it's good practice. But you can check your answers this way. VARP, bracket, highlight all the numbers, close your bracket. You'll get a variance of 24. Same thing with standard deviation. STDEVP, bracket, highlight all the data, and you'll get a standard deviation of 4.89. So with our second data set, there's 9 pieces of data. Let's just verify that. Highlighting all the values, there's a count. Count equals 9. So let's just plug that up there. And let's enter these numbers down here. We should get a total of 46 if we do that right. 46. And copying this across. So the first thing we'll have to do is calculate the average of our data set. The average equals a yucky number, 5.11. So we're going to estimate our values here. X minus that value, going a little quicker here, finding the difference. I will go to 2 decimal places. I'm using Excel, so Excel is not going to go to unlimited decimal places here. Let's just make sure that's correct. We're going to square that value. Yeah, these values are all getting a little crazy. Let's just reduce this to 3 or 4 decimal places. And that is what you should be getting in that last column as a rough estimate, because there are some rounding differences. So the process is the same. We're going to add up that last column, and we're going to take this to calculate the variance, which is going to be 40.889 divided by 9. There's our variance, and our standard deviation is the square root of our variance. So we can also verify using Excel in the functions that we have. VARP, highlighting all the pieces of data in our data set. We get a variance of 4.543, which is the same as what we calculated. And same thing with our standard deviation. There's going to be some rounding differences. If you followed along with the previous 2 examples when the numbers were more were discrete, were whole numbers, if you can follow along that process, you're doing good. So we'll continue this chapter in the next video.